Imagine you're 20 years old right now and you're aiming to have $1 million in your RRSP by the time you're 65. Assume that you earn 8% per year compounded annually. How much money would you have to contribute each year to reach your goal? How much money have you contributed in total? And what was the interest? Now, first of all, let's decide if this is the amount equation or if this is a present value question. So we have yearly contributions. So money is going in into a piggy bank that's going to be growing. Now, because it's accumulating into one large sum, we know that this is going to be an amount question. So in amount, we have our ARIN. We know that the final amount we want to have is 1 million. 1 million has 6 zeros. R is what we're looking for. Interest, 0.08%. And it's divided by 1 because it's compounded annually, so it stays the same. And the number of years, so 65 minus 20, that gives us 45 years. Let's substitute this into our amount equation. A is equal to R bracket 1 plus I to the power n minus 1, all divided by I. So I have 1 million equals R times 1 plus 0.08 to the exponent 45 minus 1. All of this is divided by 0.08. Now, we're going to use algebra to solve for the R. First thing I'm going to do, because this is a ratio, I'm going to cross multiply. I'm going to take my denominator on the right side and multiply it with the numerator on the left. So 1 million times 0.08, that equals R times this entire bracket. Before I simplify, I'm going to solve for my R. I know that if I type this into a calculator, I would get a number. It would be a number that has lots of decimal spots. So instead of me rounding it right now, I'm going to keep it. And instead, I'm going to divide both sides by that number. 1 plus 0.08 to the power 45 minus 1. 1 plus 0.08 to the 45 minus 1. Now these divide out because they are the same thing. And so my final R is equal to 1 million times 0.08, all divided by 1 plus 0.08 to the 45 minus 1. Okay, let's put this into our calculator to solve. Let's move this over. 1 million times 0.08. I'm going to hit equals. I get 80,000. Divided by, and then I'm going to put two brackets now. 1 plus 0.08, close the bracket, to the power 45, minus 1, close my bracket, then hit equals. Final answer, 2,587 and some change. So R is equal to $2,587.28. So this is the total amount I'm putting in every year. Yearly deposits. Now, part B, how much money have we contributed altogether and how much of it is interest? Now, this person has put in $2,500 every year, and we want to know how much they've contributed in 45 years. So we're going to multiply it by 45. 2,587.28 times 45. $116,427.60. So 116,427. That's a good sum, but it's not close to what $1 million is. That means that this annuity has gotten a lot of interest. So we have 1 million minus 116,427.60. Okay, 1 million minus 116,427.60. So a majority of it, $883,572.40, was in interest. Now that's the neat thing about exponential functions. Once you give it time to grow, it's going to grow very large quickly.